happy Friday. We are gonna go ahead and do some fun algorithms as always. So what we're gonna do is we're gonna work on this one right here, level 8 Caillou. So if you can't sleep, we're just gonna count sheep. So based on this task right here, it says that given a non-integer number, 3 for example, we're gonna return a string with a murmur. One sheep, two sheep, 3 sheep. Input will always be valid. Okay, so return a string of up to n sheep. Okay, so the way I envisioned this is that if it's 0, 0, we pass in 0, we're gonna not return a string. Otherwise, if we pass in, let's see, an example of 5, then I would anticipate to see 1 sheep, 2 sheep, 3 sheep, 2, 3, and 4 sheep. Let's keep going. 4 sheep, 5 sheep. 1, 2, 3. Yep, 1, 2, 3. Okay. So an edge case here to think about is the fact that if n is equal to 0, we can go ahead and just return an empty string. Otherwise, what we're gonna do is we're gonna go ahead. Oh, interesting. That's so interesting. Okay, cool. Okay. I get to see that. Okay, that is very helpful when I go ahead and do these things. I see. Okay, so what we're going to go ahead and do here is that we're going to say that we're going to iterate up to n. And then for every number that we loop through, for every number, return the number plus sheep ... Then we're gonna return the string back. That means we also have to initialize an empty string as well. Okay, so if n is equal to 0, we want to go ahead and return an empty string back. Otherwise, we're going to say the output is equal to an empty we're going to initialize an output and assign that to an empty string right now. And then we're going to say that for num in range of length, no, we'll do n plus 1. Well, for num in range n, we're gonna say because usually when you pass into range, it's inclusive. What it takes in is inclusive, and then this part will be exclusive. So we're gonna say inclusive. We're gonna start at 1 because we already handled the edge case of 0 right here. So we're gonna go from 1 up to n plus 1 because it will only go up to n, but we need to include n in the second portion of this range function. So what we're gonna do is say output plus equal, and we're gonna do it in an f string. In an f string, f string of num sheep ... We're going to return output. So essentially what this is saying that we're going to go ahead. So what an f string is, it's like a template literal in JavaScript where it's actually pulling out that variable, and we're going to go ahead and use that variable into our string, making it a lot more dynamic. So we're going to say that for every, output right here, we're going to ahead and initialize it to an empty string. So now we're going to go ahead and start at the range of 1. And we're going to say that 1, so output string is going to equal to 1 sheep ... And then now we're going to go back and loop again, which should be at 2, and it's going to keep adding on to the string of 2 sheep ... So this is what I anticipate to see for output. Yes. Is there any way to optimize this? That's a great question, but let's talk about time and space complexity for this. Time-wise, it'll definitely be O of n because we have to iterate up to n amount that it's passing for n. Loop through for n for each num in n, and then space-wise, it'll be O of n as well, because we need to go ahead and create the output string. And the output string could grow depending on how much we have to loop through for num. Let's see. Time space is this. Is there a way you could make it better? I'm trying to think, like, could I use a list comprehension? Would that be helpful in this case? Because I could always join it back with a string. But I think this should be okay too, because I was thinking that we can go ahead and create a list comprehension. So we'll create an array, and we're going to say that return f num sheep for each num in n. You could do that. You should do that. Okay, because I should stay away from doing, I think this will actually be O of n squared, because each time output will be creating a new string, because strings are immutable. I think, yeah, this should be O of n squared. So this, hi Richard, hi Apu. Sorry, long time no see. So yeah, so I don't like this idea of doing the string plus equal. So what we're gonna do is we're gonna do in list comprehension instead, and what that will entail. Do I need to assign it to anything? Yeah, I should. Okay, so we're gonna say that f of num sheep dot for num in range of 1 through num plus 1. So this one should return me back that string, and I should be able to say that I want it to be joined back into a string. Doing this will actually be time is O of n, space is O of n as well. F of num sheep. You can't do that, huh? For num in, oh, that's right. For num in range 1 of n plus 1. Yeah, that would be a lot better to do it in a list comprehension versus what I was doing earlier. Okay, commit action, add in string. I would love to know what others have created as well. Yeah, I know, Richard. Yeah, so the Adlin does come every once in a often, because yeah, it's crazy. Because I didn't see the notification before. Really? Your output space is excluded. Your output is excluded when calculating. Really? Because I always thought the output space was considered part of the space as well. So could you elaborate a little bit more on what you mean by the auxiliary space? Because my understanding is that if you're using space anywhere inside the code, that is considered as well. Welcome back. Hope you guys are having a great Friday. Forgot to charge my laptop. It's not gonna make it. So, yeah. There we go. Yeah, I love to know what you have to. Okay, so because in my head, if you go ahead and add, so if I initialize it to a string like this, and I keep adding on the S string to a string, wouldn't that be O of n? That in my head, that makes sense to be O of n squared because we have to keep remaking a new string every time, because strings are immutable in Python. Therefore, that would be the time complexity of O of n squared, versus if I use a list comprehension, using it in a list instead. Yep, and that would be time of O of n, right? That's what let's say that rather than the way you're doing it now, that you create an array. That you create an array, sheep 1, sheep 2. Yep, then that extra array you would count. But wouldn't, because isn't that what I'm kind of doing here though in this output? Oh, but not if you're building a string and returning it. But wouldn't you still have? Yeah, I love to. Yeah, I want to elaborate. Just make sure I solidify this understanding, because wouldn't I still be building a string in memory though? Because I need that output string, and I'm building that in memory. Code Wars is going well. Yeah, I'm learning a lot about Python syntax and everything. So, but yeah, I'm also doing lead code on the side too, as well with Code Wars. So, welcome to the chat though. Yeah, but because yeah, my idea is that using this creating the output string, that is building space in memory. Yeah, that's building memory, or adding space in the memory. So because you need to reference it later, so I thought I was creating that output string here into memory. So technically it's just a builder. Sounds good. Thank you for letting me know, Richard. String builder approach. So then so if I'm building it in memory, doesn't that increase the space complexity? Ah, so there's a difference between the output space and the auxiliary space. Could you elaborate more what what auxiliary space means then? Is that just like, is it auxiliary space? Because I'm trying to differ between the output space and auxiliary space. So the auxiliary space means that like is this something that you don't create and it's already like, say for instance it was an array at first. So say for instance it was given to me as an array of 1 2 3 4 5, like that. So that would be auxiliary space, versus me creating this output array. That's a different kind. That's not something that counts for space memory. Oh, so any additional data structures that you might need in reaching your result isn't actually returned. I see. But in this example, this output string, isn't it being returned? But it's being returned back in a string. So in my head, that to me still counts as like returning some space, some memory. Any additional data structures you might need in reaching your result that isn't actually returned. Yeah, because this to me is the auxiliary. I'm not good at typing this, but auxiliary. space, and then this one is just an output space. Auxiliary space. Alright, let me comment this out just in case it won't run again. Sorry, you were thinking up here, 19 to 22. Is that what you're thinking of? Oh, yes. Okay. Okay. We'll focus on this. Okay. Yeah. Okay, so your output string right here. But for this output string, since strings are immutable, wouldn't that be recreating an output string every time though? Therefore, it'll be O of n squared because you're adding the new string, or you're creating a new string every time, correct? Yeah, no worries. Cause my understanding is that there is a difference between no worries. No, this is a good conversation to have. This is a good conversation to have. Because my understanding is that there is a difference between plus equal to a string versus. No worries, no worries. Okay, so yeah, no, good conversation to have to figure it out because yeah, it's good conversation to have because I definitely want to know from different perspectives as well. So, all good conversation to have. Yeah, because my understanding, there is a difference between initializing it with a plus equal to a string is different from adding it to an array where you do all one operation to add to the end of it. But yeah, no worries. Yeah, it's all about the difference of like the data structures in languages. So no, definitely good to know. So just to make sure. Yeah. Okay, so we're going ahead and submit it. Okay, so sometimes maybe this one liner might be better, but essentially that was what I was doing. I was saying, hey, let's create a list comprehension, and then we're just going to join it back together. Yeah, you could definitely do this, but the time complexity is not as good as using a list, which is just. I almost said that a list is essentially the same thing as an array, but technically there is a slight little difference between the two. So I want to be cautious of how I say that. Yeah, but let's go ahead and do this top k frequent element. I will have to conquer this question because it's always coming up and I hate k things. But we're gonna figure it out today. We're gonna do it together today. So let's go ahead and read the prompt. So it says top k frequent elements. So given an integer array of nums and an integer k, return the k most frequent elements. I have used this platform before and I have seen this leak code before. Oh, are you talking about Code Wars? If you're talking about Code Wars, yes, those were other people's submissions. When you see those solutions like that, it's the top solutions that they have seen. So you are right that those were not my submissions. So my submissions are slightly a little different. Sorry, I have another charger. We'll be okay. Yeah, for Code Wars, yeah, those are the top solutions that they have seen from other people. So, yeah. But I don't know if you guys have seen this before, but this is top k frequent element. So as you can see from the prompt here, so we're given an integer array of nums and an integer k. We're going to return the k most frequent elements. You may return the answer in any order. So we're going to receive a list of integers. We're going to return the top k elements from the list. So for here, fortunately, it's all sorted out, but I'm gonna go ahead and create a list that's not sorted. And then we're gonna say the k is equal to 2. So it does. It does. So that's why I really definitely want to get better with this kind of problems. I'm not a fan of it, but we're gonna do this and we're gonna figure it out so we get it resolved. But yeah, so fortunately in these input solutions, it's sorted. But then I'm just trying to think of like other edge cases. I don't think that it's always going to be sorted. Fortunately, in this case, it was sorted. But what we're going to do here is that we want the top two elements here. So the way I envision of solving this problem is, if you heard of the frequency counter pattern before, we're going to go ahead and do that. And the best way to keep track, we're going to track how many times a value pops up. And to do that, we're going to use the frequency counter, and this is done with an object, and we're going to iterate through the list, increment the count of the values seen. So say for instance, we are gonna go through with our example right here. So and the best way to keep track of this is with the key value pair with objects. So we're gonna say 3, you're gonna pop up. Okay, I've never seen you before, so let's go ahead and initialize you to 1. Alright, we're gonna keep iterating through the rest of the list. Now we're gonna see we hit 2. So we're never seen 1 before. We're going ahead and increase it to a 1 because this is the first time we've seen it. Likewise for 4, 1, 7, 1. Maybe it's prettier to see it this way with objects. Let's go ahead and do it like this. But as you can see, after the 7, we hit another 3. So what we're going to do is we're going to say, hey, we've seen this 3 before. Let's go ahead and increment its count. So we'll do that for the rest of it as well. So you see that there's 2 more 2s afterwards. So we can say previously it was 1. So 1 plus 2 equals 3. So now what we're going to do is we need the top 2 elements. So we're going to return 3 and 2 here. So in no specific order, well, we can do a 2, 3. No specific order, we're going to have to do a 2, 3, just like this. And afterwards, we're going to go ahead and return the top 3. And so what I would do is I would sort by the values afterwards. Sort by values from highest to smallest, and then we'll just return the top k keys. Top k keys, which will be 3 and a 2. So if we go ahead and sort it, it should look like this. Okay, let me make that a little prettier. And so you can see that a little bit better. So I envision our object to look like this, and then we're just going to go ahead and sort it by the values, and we're just going to keep going and return the top k elements. So the way to do that is, as I mentioned before, another edge case to think of. Well, I want to think about edge cases first too. Edge cases, if list is empty, then we're just going to return an empty list because there are no top k elements. Also, could we possibly have more? Could k equal more than the values we see in the list? Because say for instance, k is, in this example, what I see is 3, 3, 3, and a 2, 2, 2. But k is asking for top 4. But that's not possible because we only have 2 elements right here. So therefore, could there be a case like that? There possibly could be. And if so, should I just return back an empty value in lieu of, because yeah, for sure it will return 3 and 2, but I still need 2 more spots. Could that be a case? That's an edge case to definitely think about, and definitely thinking about negative numbers. But it looks like from the constraints here, negative numbers are a possibility as well. So, yeah. So this is a possibility as well. And our number's length could be from 1 to 0. That's a good case to think about, because if the element is, what if the element is 1 and k equals 1, then we can just return that element right away. Just in lieu of things, because I definitely want to work on speed with my algorithms a little bit here, we will go ahead and create this as well. So we're going to create a count. We're going to say that for num in the nums list, we're going to say that the count of the value of the num, we're going to say in Python, this is how you do it. We're going to get the number. Otherwise, if we've never seen it before, we'll go ahead. We're going to go ahead and initialize it to 0, and then we're going to increment it by 1. So, as you can see, just for visual purposes, let's go ahead and print out our object right now so that you can see what... Oh no! Let's see. What is going on with the network? Let's see. Oh no! Okay, I think... Oh. It's okay. Interesting. Don't look yet. Okay, let me see. Hold on a second. Let me just, for purposes. You know what? It's okay too, because what I can do is we'll run it in our Python. Not this one, but this one. Let's go ahead and run it in our VS Code. Not that I can't, not that I'm still here. I'm still here. Oh yeah, that's weird, because I was like, what's up with the network access thing? So, but it's okay. Let's go ahead and do it in here. Compress. Top K. We'll call it top K pi. And we're gonna go ahead and do... Oh, okay, good to hear. Okay, I don't know. Yeah, I'm not sure what happened there. Maybe it's my internet access. But nums. So it's gonna take in a nums and it's gonna take in a k. And we're gonna say in this one, I feel like it should be a little bit more explicit like this as well. Okay, so as I mentioned before, we're gonna keep a counter. So we're gonna say counter equals, I know that there is a counter function. Hello, thank you for following. Thank you for coming to hang out. So we're just doing some algorithms in Python here. So what we're gonna do is we're gonna keep a counter. I know that there's a Python function counter, but I don't want to use it. Well, I guess you could. But you have to import it from a math function. Oops. I know that you have to import it from a math function, because what it will do is it will do the counter import from math library. We're gonna import counter, and then we're gonna say that count nums is equal to counter of nums. So let me go ahead and just print this out. print count nums, and in here we also have to say top k frequent elements, top k frequent. We're gonna pass in, where are we gonna pass in? Say for instance, yeah, I lost my example, but it's okay, we can still work with this. Oh, we're gonna do 2. And then what we're gonna do is we're gonna go ahead and run the file. So we're gonna do python feb top k from math import counter. I'm pretty positive that is import counter python. From collections, excuse me there, collections, we can import counter. Name list is not defined. Name error of the list is not defined. So from the list, it's not defined. Top K elements. It should be for so we're gonna, from collections, we're gonna import counter, correct? So now it's saying that my list is not defined. It can't find my list. I want to just go ahead and print count nums because I definitely want to show you what it is displaying. Because as you can see right here, what the counter is doing, it'll create that frequency counter. And it'll look at each key and increment the values for you. It'll do that. But top K. So I'm calling, so this is where I'm defining the function. I'm saying, hey, let's call the function here. I'm calling the function, I'm passing in my list of values that I want to show as nums. And I'm gonna say that k is an integer of 2. And I want to return name, it doesn't like list. So I don't think, I could, yeah, I think I'm supposed to import list, but we'll do it like this for right now. Top K frequent element is not defined. Top K frequent element, because did I spell it wrong? Nope, I think I spelled it right. Name top K. Pretty sure I spelled it right. Okay, and now I indent that back. Control tab. Nope. Oh, bear with me. It was shift tab. There we go. I remember that, shift tab. Oh, I see. Okay, let me add that back then. S.top. S.top. S equals solution, and then S.top. Okay, let's try that. Thank you so much for that help, Apu. I wasn't thinking about the whole class solution, so thank you for the help on that. But as you can see, is this kind of tiny for you guys? Hopefully it's not too tiny. Let me work. Oops, that's a lot of things you probably don't want to see. So as you can see right here, it goes ahead and create this counter solution. Appreciate it. So as you can see right here, it goes ahead and create that counter method for us, and it'll keep track of the keys and the values seen. Yeah, it's so efficient because I know that you can definitely do it with an object and iterate through the list of iterate through each value in the list and increment the count that way. But if you could go ahead and import counter from this collection, it will automatically do that for you, which is kind of nice. So yeah, so with that, what we're gonna do is what we're gonna do now, as I mentioned before, we'll call this sorted, because I'm gonna go ahead and sort it by values. So we're gonna call this a sorted count. And what we're gonna do is we're gonna go ahead and sort count. We'll do sorted, and it's gonna take in an interval. Yeah. So yeah, this is like my brute force of thinking about it. So this is my brute force of thinking about it as well, and oh, with the counter method, did you do it with the counter method as well? And then what we're gonna do is we're gonna say key lambda x, and key lambda is just saying this is an anonymous function and I want to go ahead and sort it by values. And how we're going to sort it by values is we're going to go ahead and grab each specific num, and because in each key we're going to go ahead and grab the values here, as you can see, and we're going to reverse equals true. Yes, we'll get to it. Yes, definitely let me know which method you took. Oh, I forgot to use int object is not subscriptable. I forgot to. Like my programming language background, int object is not subscriptable. It should be. Count nums, so it's saying that my int object is not subscriptable. Key equals lambda. Oh, I see. No, I am actually a poli-sci major, economics minor. So, yeah, no. And my background is more of in finance, a financial analyst and stuff like that. So, yeah. I mean, I do some open source projects with some sweet work, but yeah, how about you? How about yourself? Okay, so sorted count equals sorted of count nums. Okay, so it doesn't like my count nums. And it should have liked my count nums though. It should have liked my count. Oh my goodness, how fun! No, the reason why I went poli-sci is because I almost thought I was gonna go to law school, but yeah, I didn't go to law school. But it's okay now. I did not know that. That's pretty cool. Are you more front end or back end, by the way? Sorted count equals sorted count nums. Sorted. I actually wanted to be a sorted count. It is a fun major, but a lot of essays. Equal count nums dot sort, and we're gonna sort by key equals lambda of x1, and we're gonna say the reverse is equal to true. Oh, I see. I did not know that. Which one do you like more? Your answer is safe here. Okay. I think it should definitely be sorted. So we're gonna go ahead and take out the sort. And I'm gonna take out my charger. Switch it out quickly. Oops, wrong charger. Oh, I see. You know, I never thought about that, but you bring up such a good point about that. With the UI UX, because yeah, everyone definitely can see it. No, I definitely understand that because in my mind, yeah, that's a good perspective. That's a good point that you brought up because now like it shines perspective on for me because I always thought I want to be a front end person because I feel like there's for me my experience I feel like you can't really be a full stack person. So I mean you could probably do like 60-30 or something like that, but I don't feel like there's such a thing as a full stack person. So I lean more a little bit more on the front end side because I like being able to see the product that I produce. And that's a good point to bring up. Yeah, I can definitely see that because I'm sure they are particular about the specific design. Good point to bring up. Maybe I should be a backend now. Just because you said that, I'm gonna be a backend now. Yeah, well, we'll definitely see. So I like doing backend too. I like working with um, database and authentication. It's kind of fun too. So yeah, let's see. Okay, sorry. Oh, getting a little caught there. But okay, sorted count equals sorted. Okay, so it's just my int object is not subscriptable. Count nums. Is it lambda? Lambda equals key. No, I think I did that right. Okay, yeah. Sometimes I get confused. Okay, so reverse equals true, meaning that I want it to be reversed. Okay, so my int object here, let's figure out what I did wrong there. Oh, I see. That's true. That's true. So, you learn. Remember that the input returns a string, so I don't need to convert. This fixes the error. If you gain the error after converting, in this example, I wrote Python. We're gonna say, okay, so we created that counter, and now we wanted to go ahead and do. Yeah, no, so we're still working on top k frequent elements. I want to go ahead and sort it by the values. And I want to sort the object that we receive back here. Where did the object go? Let me clear this. And let me run it. So we receive print count nums. Oops, gotta close that. Yeah. Okay, so you can see right here, here's our counter. So I want to go, x is an integer, not a list or a tuple. Because counter returns the keys. Yeah, I definitely wanted to still return back the keys and values. I wanted to still return back the keys and values. Sorted count equals sorted count num. So we're gonna pass in the counter object, this iterable object item, and then we're gonna go ahead and say that we're gonna sort by the values. So grab me the values. What you want is count nums 1 for the value. X then. Wouldn't it be X then? For okay, it does not like that. That's right. Okay, so the reason why you say 1 is because that grabs the value. It doesn't grab the key. Oh. Sorted count equals sorted count nums 1. Let's see. Ooh. You know what it is? Okay, so since we're using, because that's grabbing the keys, right? When you state it like that, count nums should be 1, 2, 3 in this case. It should be, that's the keys, right? Because what I want to do is be able, yes. So yeah, so in my mind, yes. So count nums, what it is that I need to do too. Yeah, so okay, so I want to grab both the keys and the values. And to grab both the keys and the values, I forgot that in objects you can use dot items. And what that will do is grab keys and values, and then we can go ahead and specifically point out and just grab the values. So this point sorted count. Oh yeah, I know. Counter is okay, so perfect. As you can, yeah, so by taking out the keys and the items, I know counter is such a, it's a weird object. Yeah, I definitely have to play with it a little bit more. But yeah, as you can see that we got the key and the items and we sorted by their values right here. It did just that. But now what we're gonna do is we're gonna go ahead and say that we wanted it to return a list back of the top key. Yeah, so what we'll do here is we're going to return, in my mind, when I think about, like, when I see a list that I want to be returned back, I do think about, like, a list comprehension. That's what I've come to figure out with all these data structures. It's almost similar, but not the same thing. It's almost like a list is almost like an array, but it isn't. So, yeah, I know it's interesting like that. So what we're gonna do here is when I see that they want a return of a list back with values, I kind of do always, well, I try to think about like, can I do that in a list comprehension way? And with that, you can definitely do it with a list comprehension way, because what we're gonna do is we're gonna go ahead and iterate through the sorted counts right here, and we're only gonna grab the the keys value. And then so what we're going to do here is we'll say that return num for num. We're going to return the num for num and the value in value in sorted count, because we do need to consider that it is a key value pair in sorted count, and we only, with the power of Python, you can do slicing. I mean, we only want it up to k amount, so this will stop at that specific k. So it didn't return anything. Return num for num, value in sorted count, correct, and we only want it up to the k amount. Return, I want you to return, yeah, so we're gonna create our object. We're gonna go ahead and sort it by the keys and values, taking the values, and now we wanted to return num for the num value, for the key value pairs, for the key, maybe num for num value in the sorted count, of k. It should have worked then, though. But when I run it, return, I want you to return, because it should have returned back. Return list back with the num for the num value pair in the sorted k. We're gonna slice up to k amount. Num for num in the sorted count. Num value in the sorted count. Print. If I print it, it should work too. Because otherwise... Okay. See? My print does work. My return should have worked too. Return. I want you to return. Okay, so... I want you to return num for num. Because we don't care about values anymore. Nope, that's not it. I want you to return the number for each num. I'm not printing my return. Because, are you saying that I should put print around it? Because in my head, if I just return it, shouldn't it be printed? S tab K in print. Oh, I see. Okay, so I definitely will have to work more on Visual Studio Code, so thank you for that. Oh, there it is. Thank you for your help on that. Oh, I see. Because in my head, if you say return, return is a way... Well, return should have... prints to the console. That's my way of understanding it. So feel free to let me know. And then return should have done that too. Hey, I couldn't have done it without you. So thank you for your help on this. Yeah, I definitely need to go and look at that stuff. Print and return. Cause yeah, I definitely have to play more with my Visual Studio Code. But yeah, let's talk about time and space wise. Time wise. Oh, I see. That's hence why I have to return to... I had to call this because, yeah, they will return to this. I see. I see. Okay. I see. Thank you for explaining that. Yes. Time-wise, when I think about worst case complexity, because when I think about time and space complexity, I'm always thinking about the worst case scenarios. And worst case scenarios, from looking at our specific code right here. Yeah, hence why I haven't done it. But so thank you for the help on that. Now I know. So I'll have to practice more on my Visual Studio Code. Yeah. So when I think about time and space for this, time-wise, it's O of n log n. Because when I create a counter object, it will be O of n operation, but sorting the items itself, it's going to be O of n log n. And for this, it will be O of n. I'm trying to think if this this specific line 8, if the time complexity is O of n times k. But I don't think it is. Well, because we're only going up to k amount, so not necessarily we're going through each n amount, because we only need two k's. We don't need to go through the whole entire list. So, so this, I'm gonna say it's okay. For the time complexity, but the worst of them all that slows down the whole algorithm is the sorting part. So time complexity is going to be O of n log n. Space wise, it will definitely be since we're only returning up to k amount, I'm going to say O of n times k. Yes, perfect, thank you. So that's and I'm gonna say that space-wise is O of k. as well, because we only need K amount and we don't need the whole O of N amount. So that's what I'm gonna say. Yeah, so maybe later I definitely wanted to get into bucket sorting, and I also definitely wanted to get into heaps, but we'll come back another day and definitely work on that because I have to go. So yeah. Oh, that's interesting. All of a sudden it froze. Let me go to Windows. Nope. Go to display. Okay. Sorry about that. Yeah, no, yeah, I've heard heaps are good for this, but then at the end of the day, I heard that with heaps, it is O of n log k. I can't remember what the time complexity was, but then from neat code, bucket sorting is better because that will give it the O of n operation. But yeah, I definitely want to get into heaps as well. Yes, yes. Yep, that's basically what I did. Yeah, I definitely have to work more with heap queue methods because I started working with that as well. Yeah, from neat code he stated that doing the bucket sorting it will be all of an operation. So I definitely want to get into that as well. So yeah, I've been learning a lot from heap queue. I One thing I learned about heap queue is its default is min heap, and in order to implement a max heap, you need to negate the values when you add it in. So been trying to learn that and work with that as well. So much to learn, so much to do. So I hope you'll be back, and maybe I'll get to see when you do some of your streaming some days. So we'll definitely do more streaming. So thank you for coming to hang out. I have to get going though, so let's do more. Oh my goodness! Hi, Farky. Sorry, I was just about to head out. Stop by again. That's so funny. I know it is. It's way too